Hello learners, in this lesson we are going to learn about simple linear regression analysis. Simple linear regression analysis is a statistical tool that gives us the ability to estimate the mathematical relationship between a dependent variable and an independent variable. In simple linear regression, our objective is to use the data to position a line that best represents the relationship between two variables. If we are interested to study the dependency of a variable on a single variable, we use the method of simple regression. Here you can see some situations where we can use simple linear regression. A scientist wants to know at which level of sound pollution will affect human health. A computer scientist wants to compress an image for minimum storage. An economist wants to investigate the relationship between the petrol price and the inflation rate. A sale manager wants to predict the total sale in next year based on the number of staffs. Simple linear regression analysis involves one dependent variable and one independent variable in which the relationship between the variables is approximated by a straight line. The general form of simple linear regression model is y equals to beta 0 plus beta 1 x plus epsilon. Here, beta 0 and beta 1 are the parameters of the model and epsilon is a random variable referred to as the error term. The error term accounts for the variability in y that cannot be explained by the linear relationship between x and y. Each distribution of y values has its own mean or expected value. The equation that describes how the expected value of y, which is denoted by E of y, is related to x is called the regression equation. The regression equation for simple linear regression is E of y equal to beta 0 plus beta 1 x. The graph of the simple linear regression equation is a straight line. Beta 0 is the y-intercept of the regression line, which measures the value of y when x equal to 0. Beta 1 is the slope, which measures the average rate of change in dependent variable per unit change in independent variable. And EY is the mean value of y for a given value of x. If the values of the population parameters beta 0 and beta 1 were known, we could use simple linear regression equation to compute the mean value of y for a given value of x. In practice, the parameter values are not known and are needed to be estimated using sample data. Sample statistics, which are denoted by B0 and B1, are computed as estimates of the population parameters beta 0 and beta 1. Substituting the values of the sample statistics B0 and B1 for beta 0 and beta 1 in the regression equation, we obtain the estimated regression equation. The estimated regression equation for simple linear regression follows y hat equals to B0 plus B1x. The graph of the estimated simple linear regression equation is called the estimated regression line. B0 is the y-intercept and B1 is the slope of the graph. In general, y hat is the point estimator of y, the mean value of y for a given value of x. We will simply refer y hat as the estimated value of y here. Here you can see the estimation process for simple linear regression in our graph. In the first box, we have the regression model y equal to beta 0 plus beta 1x plus epsilon, and from the regression model we can get the regression equation as E of y equal to beta 0 plus beta 1x, and finally here we have the parameters beta 0 and beta 1 which are unknown. We have to estimate these unknown parameters. To estimate these parameters, we have to collect data from our sample and we have to collect the values of the dependent and independent variable. After collecting data, here we have our estimated regression equation, which is y hat equal to b0 plus b1x, where b0 and b1 is the sample statistics, and we can estimate or calculate b0 and b1 from the sample data, and we can put these values in the estimated regression equation. b0 and b1 are the estimates of beta 0 and beta 1. Here are the assumptions of simple linear regression. The relationship between the dependent and independent variables is linear. The error term epsilon is a random variable with a mean or expected value of 0. That is, expected value of epsilon equal to 0. The variance of the error term, which we denote by sigma square, is the same for all values of x. The values of the error term are independent. The error term epsilon is a normally distributed random variable. Now look at the properties of regression coefficient. Regression coefficient is independent of origin and scale. Correlation coefficient is the geometric mean of the regression coefficients. That is, if byx is the regression coefficient of y on x and the bxy is the regression coefficient of x on y, then r equal to square root of byx into bxy. The average of the regression coefficients bxy and byx is greater than or equal to r, where r is the coefficient of correlation. If the regression coefficient of y on x is greater than 1, then the regression coefficient of x and on y is less than or equal to 1. Regression coefficient r is not a pure number.